Today we're going to talk about solving inequalities. Solving inequalities is just like solving equations, except in an inequality you want to find an interval of numbers that satisfies the inequality as opposed to one number. To do that, we have to find the roots of the inequality, of the equation. What are the roots? The roots are the numbers that make that equal to zero as an equation. And in the case of a rational function, it's the numbers that make the denominator zero as well. So we find those roots, and we use those roots to divide up the number line, and then we test values on each interval of the number line to see if they satisfy the inequality. So we're going to look at polynomial inequalities, absolute value inequalities, and rational inequalities, and see how we can solve those. So here we have a polynomial inequality, and the inequality is 2x squared plus x greater than 15. So we want to find the values of x that satisfy this inequality that makes 2x squared plus x greater than 15. So the first thing you want to do is, you might recognize this is actually in a quadratic form, and so in quadratic form we put everything to one side. So we'll have 2x squared plus x minus 15 is greater than 0, so we subtracted 15 from both sides. The next thing is you think of this as if it were an equation. So if this were an equation, there would be an equal sign here, and to solve a quadratic equation like this, we would either factor or we use a quadratic formula. In this case, we can try factoring. And so if we factor it, we get 2x minus 5 times x plus 3 equals 0. So you can try trial and error and factor it into those two factors. And so what you find is the solution to this equation is, if you set each of these equal to 0, you end up with x equals 5 halves from this factor, and x equals negative 3 from this factor. And those are what we call the roots of this polynomial inequality. So these are the roots. So that's not the answer, but those divide up the number line. So what we do is we draw a number line and put these two roots on the number line. And so here we have our roots on the number line. And now we're going to pick numbers in each of these areas to test on the number line if they satisfy the original inequality. What is the original inequality? It was 2x squared plus x minus 15 was greater than 0. That's the original inequality. So we're going to pick numbers less than negative 3, between negative 3 and 5 halves, and greater than 5 halves. So let's do that. So firstly, if I pick a number less than negative 3, let's say we pick a number a negative 4. So if we pick negative 4, we're going to test it in this inequality. In other words, we're going to have 2 times negative 4 squared plus negative 4 minus 15. So we have to evaluate this. If we evaluate this, we get 2 times 16 is 32, minus 4 is 28, minus 15 is 13, and so you want to know, is that greater than 0? And so, yes, that's true. So that means that negative 4 is in the interval where there's a solution, and that means that this is part of our solution here. So we can put a yes or a tick mark here on this part of the interval. So similarly, you're now going to pick a number in between negative 3 and 5 halves to see if that number satisfies the inequality. And a nice number to pick in between these two, because they have a negative and positive, is 0. So we're going to do the same thing and test 0 here. So we plug in 0 here, we get 2 times 0 is 0, plus 0 is 0, minus 15. That gives me an answer of negative 15. Is that greater than 0? No, that's a negative number, it's not greater than 0. So this doesn't work out here. So 0 is not in the interval where there's a solution, so we put no for that interval. So finally we could pick another number bigger than 5 halves, and let's pick 2. So 2 is bigger, 2 is not bigger than 5 halves. Let's pick 3, because that's 2.5. So 3 is bigger than 5 halves. We plug back 3 into the inequality and test that. So plug in 3 into the inequality, we evaluate this, we see 2 times 9, 2 times 3 squared is 18, plus 3 is 21, minus 15 is 6. Is 6 greater than 0? And yes, that is greater than 0. So we see 3 is also in the interval where there's solutions, so that's yes, that's part of our answer. So how do we write this solution? We're saying our solution are numbers less than negative 3 and numbers greater than 5 halves. And between negative 3 and 5 halves, there's no solution. So how do we write that? We use interval notation. And so what we do is we say our solution is from negative infinity all the way to negative 3. Now we don't include negative 3 because this is a strict inequality. So we put a parenthesis there. And then we go union, or, and then we go from 5 halves to infinity. And so you'll find that this here is the solution to the polynomial inequality. Now let's look at this graphically. What does this look like? So if I graph the original inequality, 2x squared plus x, so that's a parabola here, with the vertex at the origin, and then 15, which is a horizontal line, y equals 15. This is what it looks like. And what this is telling me, this solution, is telling me that 2x squared plus x, the parabola, is bigger than the line, is higher than the line, between negative infinity and negative 3. So about here, so this is, let's say, negative 3, where the parabola comes above the line here, and also from 5 halves, so that would be around here, from 5 halves onto infinity. But between those two numbers, it's below the line 15. And remember, we also, when I checked these numbers, I checked it into the equivalent quadratic formula, quadratic inequality, 2x squared plus x minus 15 was greater than 0. Either one would work. Either one would work. That's just as equivalent as 2x squared plus x is greater than 15. Okay, so now we've seen how to solve polynomial inequalities. We know how to give roots, and we know how to check those numbers in the intervals. We can now look on to another type of inequality, very similar, an absolute value inequality.